Hello, my name is Vinh Tang. This is my GSCM 510 final project presentation. For introduction, my company is Nike Inc. My position is production supervisor. My span of control is the new sportswear department, otherwise known as NSW, where we manufacture development airbags that goes into our Air Max 270 as well as our 720 shoes. My industry or market is manufacturing footwear and apparel. My geographical focus is the Nike airbag manufacturing plant right here in Beaverton, Oregon. Here is a high-level video of the manufacturing process of these airbags at our plant in Beaverton. So for our proposal, we would like to implement a secondary inspection for scrap parts to improve our first pass yield percentage. So at the current state, once a part is determined to be defective and scrap, they are thrown into a gray garbage bin from the quality control station for recycling. In the future state, we would like to implement our secondary inspection by using these yellow bins, which are categorized based on defect codes for for a secondary inspection from the line leader. For our project scope, we want to improve the department's first pass yield percentage and overall energy and material consumption by reducing the number of good parts being scrapped. As shown in the video, our manufacturing process currently recycles 90% of our excess material and scrap and turns it into raw material for later consumption. In addition to our current strategy for a circular economy, our project will create new opportunities for growth from a business standpoint and a more circular economy by reducing waste and drive for greater resource productivity. So for our current status, the NSW team has implemented a 3-week trial of label yellow bins to help reduce the overscrapping of good parts on one of our production lines. For week 1, we measure the amount of good parts being scrapped every 2 hours at the current state without the implementation of a secondary inspection on Keyful line 18. Finding of good parts were recorded into a database. For week 2 and 3, a secondary inspection has been implemented, and the team is asked to categorize their scrap corresponding to the labels on the bins. The production lead will check the bins every 2 hours, and the results for any good parts that should not have been scrapped will be recorded. In our design thinking, at the beginning of our process, we wanted to visualize the whole process and ask, what is it? We know that the job it accomplishes is to create airbags that goes into our shoes for final assembly. Raw material comes from 2 primary sources, the extrusion department as well as from our raw material supplier. From there, the material is used to create rolls of plastic, each weighing approximately 400 pounds, and are sent to our forming stations to create the airbags. The parts that come off of the forming stations are cut into individual pieces and is quality inspected before they are shipped for final assembly of the shoe. Like our project with creating a better mousetrap, in our design thinking, we want to know we could improve our first pass yield percentage, meaning less parts will be scrapped, and support the circular economy by reducing our energy consumption, while improving the amount of parts we deliver to our suppliers. We first began our journey by collecting data, analyzing the data, and from there develop innovative strategies on how to improve our first pass yield percentage. This is the result of our data collection for the first week, before any secondary inspection was implemented. From the results, we can determine that our team scraps approximately 73 pairs per day, which means additional processing time to get the same amount of bags to our vendor is required. As mentioned previously, because of the additional processing that is required to hit our delivery commits, we are having to spend additional resources, such as electricity, to maintain oven temperature and raw material to create the additional bags. Although much of the scrap gets recycled, there is a limited number of time the scrap material can be recycled and repurposed before the quality grade is unable to be used and are sent to landfills. We then develop a job map with the step for the quality control station. So for the job statements, the first one is collect parts from the cutting station. Second is group parts for inspection. Third is inspecting the parts. And fourth step is bagging the parts, or if the part is defective, then scrapping the parts. For our outcome statement, we want to minimize the movement of parts, maximize part efficiency, minimize opportunity to mix right and left bags because each pair has a left and a right, and then they look very similar. Maximize grouping efficiency, minimize bad parts being shipped to our customer, maximize part inspection process. We would also like to maximize bagging of the parts to be shipped out and minimize the number of good parts being scrapped. As a process of creating our prototype, we wanted to get the voice of our customer, which in this case our stakeholders are the line leaders as well as the production component operators who perform the inspection. We asked what the employees wanted, and the response to us was they require a fast and efficient way to discard scrap. They would also like point of reach, so that way they are not having to move significantly far to scrap these parts, as well as once a part is scrapped, it can be easily tracked. This will help our production line leader because they have additional responsibilities within their jobs. So what is currently being done in other departments? So as of right now, the standard step is to use the gray garbage bins, and we currently do not have an alternative available. So as a team, what we must offer for our stakeholders is develop a system that improves our first pass yield percentage. It does not create non-value added work for the operators, as well as meet all of the requirements of the employees. So using our outcome statements, we develop selection criteria, which consist of efficient, accurate, quality control, and risk mitigation. For our Pew matrix, we use the gray garbage bins as a benchmark and two of our prototypes and grade them based on the selection criteria. From our grading, the prototype that received the highest net score is the yellow bins on the rolling cart because it provides accurate tracking of the scrap parts. It reduces clutters because unlike the picture in the middle, it is not on the QC table and taking up space. And it also provides risk mitigation. So based on this score, we implemented the yellow bins on the rolling cart for our production line QFO 18. Here is the results of our outcome after the implementation for 1 week. We can see based on the data when comparing to the before implementation that there has been a significant reduction in the amount of good parts that should not have been scrapped. And from there, we can see that our first pass yield percentage has gone up due to the scrap reduction. Well, this concludes our final presentation for the project. Thank you for your time and have a great summer.